We take a long answer question from thermodynamics. The question is, describe the method of determination of specific heat of a solid by the method of mixtures. If this question is asked, if you write the principle of method of mixtures, we get 1 mark. For the procedure, 2 marks. For the derivation of related theory, we get 4 marks. For writing the precautions in the experiment, we get 1 mark. So we take how to present this. First we write the principle of the experiment, that is method of mixtures. When two bodies at different temperatures are mixed together, if there is no heat loss to the surroundings, then heat lost by the hot body is equal to heat gained by the cold body. This is the principle of method of mixtures. We are going to use this principle in the determination of specific heat of a solid. For this experiment, calorimeter is used. We take the procedure of this experiment. Calorimeter is a copper container and is used to measure calorific value of the material. This is placed in a wooden box, and the gap between calorimeter and wooden box is filled with cotton-like insulating material. The instrument is closed with a insulating top. Stirrer is attached to the top to stir well the content of the calorimeter, and using the thermometer attached to the instrument, the temperature can be measured. This is the description of the experimental arrangement. The procedure of the experiment is, first the weight of empty calorimeter W1 is measured. Water is taken in calorimeter and the weight W2 is measured. At room temperature T1 degrees Celsius, solid is taken. A solid is taken as small pieces and heated up to temperature T2 degrees Celsius, and this is mixed with water in calorimeter. The content in the calorimeter is stirred well, and the final temperature T3 degrees Celsius is noted. In the experiment, we are measuring the mass or weight of the calorimeter, weight of the water, weight of the solid that is added to the calorimeter, and the initial temperature or room temperature T1 degrees Celsius, the temperature of the solid T2 degrees Celsius, and the final temperature of the mixture T3 degrees Celsius. By measuring these values, we are going to find the specific heat of the solid. Now the theory related to this experiment is, weight of the calorimeter, we take this is W1. Here, since mass is directly proportional to weight, instead of mass we are taking weight. Now weight of the calorimeter with water, we consider this is W2. Weight of the calorimeter with water and solid, we take this is W3. Now the weight of the water in the calorimeter is nothing but W2 minus W1. Similarly, the weight of the solid added to the calorimeter is W3 minus W2. Initial temperature, that is room temperature, is T1 degrees Celsius. The temperature of the solid T2 degrees Celsius. The temperature of the mixture, that is after adding the mixture into the container, for the final temperature of the mixture is T3 degrees Celsius. Specific heat of the calorimeter is S1. Specific heat of the water is S2. Let the specific heat of solid is X. In the experiment, we are finding the value of X, that is the specific heat of the solid. Now, the amount of heat gained by the calorimeter, using the equation Q equivalent to, that is amount of heat energy taken by a solid or a substance, Q equivalent to mass into specific heat into temperature difference, that is Q equivalent to M into S into delta T. Using this, we can write the amount of heat gained by the calorimeter is W1 into S1 into T3 minus T1. Similarly, the amount of heat gained by the water, the mass of the water is W2 minus W1 into S2 into T3 minus T1. This is the temperature difference of water. Similarly, amount of heat lost by the solid, This is equivalent to W3 minus W2 x into T2 minus T3. In this experiment, comparatively, the temperature of solid is more with water as well as the calorimeter. That means the temperature of the solid is more compared to the temperature of water as well as the calorimeter. Since we are mixing these two, the cold bodies are calorimeter and water, hot body is the solid. Therefore, I can say using the principle of method of mixtures, solid is losing the heat, water and calorimeter are gaining the heat. Heat lost by that solid is equivalent to heat gained by water and calorimeter. That means according to the principle of method of mixtures, we can write heat lost by the solid equal to heat gained by the calorimeter and water. Therefore, W3 minus W2 x into T2 minus T3. This is heat lost by the solid. This is equivalent to W1 S1 into T3 minus T1. This is heat gained by the calorimeter plus W2 minus W1 into S2 into T3 minus T1. This is heat gained by the water. Now using this, we can write the specific heat of the solid x equivalent to W1 S1 plus W2 minus W1 into S2 into T3 minus T1 divided by W3 minus W2 into T2 minus T3. This is the specific heat of the solid. While doing the experiment, the precautions we have to take are the readings are taken without any parallax error. Temperature is noted when steady state temperature is obtained. There should be no heat exchange between the calorimeter and surroundings. These are the precautions we have to consider while doing the experiment.